In today's lesson, we are going to be looking at factoring review. So factoring was a big thing that you would have looked at in grade 10. We are going to look and review over those kind of key concepts or those different types or situations where factoring comes into play, because that will be helpful in this course. So in general, first what we're going to look at is common factoring. So a common factor in itself is a number and or variable that divides evenly into all terms of the polynomial. So basically we're looking for a number and or a variable that is a part of every term, or is a multiple or factor of every term in your polynomial. When common factoring, we're looking for the greatest common factor, or GCF. And the reason we say the greatest is because in some cases there may be a single number or there may be multiple numbers that are factors, but we're looking for the largest number that is a common factor between all of them. So let's look at a couple of examples. So I look at x squared plus x. So what is the common factor between these two? Well, there's no numbers, so we know our factor is not going to have a number. The other term, so we only have x's. And if we were to break this down, this might be a little bit easier to visualize it. If I were to rewrite this, x squared is the same as saying x times x. And x on its own is just x. So what is common between these two terms? The two x's and the one x? Well, a single x is common. We have an x here and we have an x here. So that means there is a factor of x that is common between both terms. So when we factor it, we take that common term, we put it out front, and inside the bracket, we put whatever is left over. Or basically, we divide the previous two terms by that common factor. So x squared divided by x leaves me with x. X squared divided by x, x divided by x leaves me with a positive 1. So this is now factored. We can double check if we really wanted to by multiplying this through. So we'll just do this as an example. So if I multiply this through, x times x is x squared, x times 1 is x, and that brings me right back up to the beginning. So that's how you can double check to make sure you have factored it correctly. If I look at b, 2x minus 8, well, there are no x's or no variables that are in both terms, so there's not going to be a variable. So now let's look at the numbers. Well, I have 2. What are the factors of 2? Or basically, what numbers multiply to give us 2? Well, the numbers that multiply to give us 2 are 2 and 1. What about 8? Well, 2, so we'll start off with 8 and 1, 2 and 4. Yes, we could go 4 and 2, 1 and 8, and so on, just switch it up, but it'd be the same thing. So now we look for what is the largest number between these two. We should see that it's clearly 2. So that means my greatest common factor is 2. So I'm going to take the greatest common factor, put it outside the brackets, see the greatest common factor there. Now we divide the previous two terms by 2. So 2x divided by 2 is x. Negative 8 divided by 2 is negative 4. Another way you could think about it, 2 times what, just here, gives me 2x. Well, that would be x. 2 times what gives me negative 8, negative 4. And that is factored, because again, I can multiply this through and get back to my original answer. In C, AB minus BC. So two terms, there's only variables. Let's look at our factors. Again, if we want to break it down, A times B or AB, the two factors are A and B. The next one, B and C, those are the two factors there. Only two things that we're multiplying. The common thing between them is a singular B. So we have our common factor, or greatest common factor of B. In our brackets, we're dividing the previous two terms by that greatest common factor. AB divided by B leaves us with A. And then BC divided by B leaves us with C. So B times A minus C is the factored form. Finally, if we look at D, we have letters and numbers in both terms. So let's look at each part kind of separately. If I look at the 9, what are the factors of 9? We have 9 and 1, 3 and 3. If I look at the A, or the A cubed, I have an A times an A times an A. If I look at 12, I have 12 and 1, 2 and 6, 3 and 4. And then for the A, it's just the A by itself. So what is the greatest common factor between these two terms? Well, looking at the numbers, I can see that the largest number that's common between both of them is 3. And in terms of letters, there is one A that is common between both of them. In some cases, you may have multiples of the same letter, and we'll probably look at some of those examples later on. So you could have, it's not always just going to be a singular variable. Might be multiple variables, might be a variable with an exponent, whatever the case may be. So our greatest common factor then is 3A. It might get a little tricky now, but if we divide both of the previous two terms by 3A, 9 divided by 3 is 3. A cubed divided by A is A squared. 12A divided by 3A, or negative 12A, so we have negative 4, and the A divided by A removes it. So that is our factored form. If you look at the next ones, again, a little bit harder, but again, you're looking for what is similar between all three terms. So looking at the numbers between 2, 6, and negative 8, well, usually you look at the smallest number and find what factors are there, and that might help you. 2, the only two factors are 2 and 1. 2 also happens to be a factor of 6 and 8. So from there, we should know that our greatest number factor has to be 2. That's all it can really be. Now if we look at the variables, they all have x's, they all have y's, and they all have z's. So we know x, y, and z are going to be part of the greatest common factor. And the only thing that's going to affect it is what number or what exponent on each of them. Well, let's look. The lowest exponent on the x's is 1, so that's what our common factor has to have. On the y, we have y squared, y squared. So even though we have y squared on 2, the lowest is 1, so that's what our exponent has to be. Z, we have 1, 1, and 2, so again, 1 has to be part of our common factor, our greatest common factor. We can't have 2 as a factor because the other term doesn't. There is a term that doesn't have an exponent of 2. So now that we found our greatest common factor, we have to divide all the previous terms by that. Right, so focus on the parts that are similar, cancel out if you need to. 2x y squared z divided by 2x y z. 2 divided by 2 is 1, cancels out. X divided by x is 1, cancels out. Y squared divided by y leaves me with a leftover y, and z divided by z cancels out. Next term, 6 divided by 2 is 3. X squared divided by x is an x. YZ and YZ, same terms, they cancel out, so it leaves me with 3x. Lastly, negative 8 divided by 2 is negative 4. X and x cancel out. Y squared divided by y leaves me with a y, and z squared divided by z leaves me with a z. So that is my factored form. For f, same idea. Can look through. For numbers, find the smallest number, look at the factors. Smallest number is 2. Its factors are 2 and 1. 2 is a factor with all the other ones, so we know 2 will be part of our greatest common factor. Next, look at the letters. What letters are common between all of them? Well, we do have an A and a B between all of them. Look for the smallest exponent. It happens to be 1 for all of them. So this 2AB is our greatest common factor. Now to figure out what's left, once we remove that, we divide. Or we can think of 2AB times what gives me 4A cubed B to the power of 4. Either way you think of it, you should get 2A squared B cubed. For the next one, we have negative 3AB plus 1 for the last term. In some cases, your common factor may be a bracket in itself that has multiple terms within it. If we look at G, we can see that this bracket of 2x plus 1 is common in both terms. Because it's common in both terms, we can remove that entire bracket. So 2x plus 1 is going to be our greatest common factor. To factor that, we have to look at, okay, well, what's left over if I remove that? Well, if I remove this bracket from the first term, I'm left over with x. The second term, I'm left with negative 2. So that is how we can factor when we have a bracket or a polynomial as our greatest common factor. Moving on to factoring simple trinomials. So this is one of the main kind of types of factoring that you would have come across in grade 10. So a simple trinomial is one in the form ax squared plus bx plus c, where a equals 1. Or in other words, you would see it as basically x squared plus bx plus c, something in that form. If it is factorable, a simple trinomial can be expressed as a product of two binomials. So remember, binomial means two terms. The constant terms of the binomials are the integers that multiply to give c and add to give b. So these are the two key parts. Multiply to give c, add to give b. So let's look at that connection or that relationship. Let's expand and simplify these. So you should be familiar with this from the previous lesson, binomial distribution or distributive property, specifically the FOIL method in this case. X times x is x squared, x times 5 is 5x, 3 times x is 3x, and 3 times 5 is 15. If I were to simplify this, I should get x squared plus 8x plus 15. So this is now my trinomial down here. What relationship do I see between this and what I started with, or the factored form? Because this is factored. And this is my trinomial. Well, if I look at the factored form, or the trinomial, this middle term, this 8x, is the sum of my two middle terms, which also relates to the sum or the two constants in my factored form. My constant, or the c term, which we see here, is the product or the multiplication of the two terms in the brackets or the factored form. So that's kind of the connection. That's how we can work backwards, by recognizing that relationship or recognizing that connection that those two constants have with the other terms in our trinomial. So again, the second one, if we go through and expand, w times w is w squared, w times 3 is 3w, minus 4w minus 12. Collect our like terms. We have negative 1w minus 12. So again, hopefully, again, you can see the connection. Oops. Negative 1w, oops, no, plus 12 minus 12. Negative 1w is the sum of positive 3 and minus 4, which we get, again, from the two terms in our factored form. The last term, the constant, negative 12, is a product of negative 4 times 3, or the two terms. So again, seeing that connection between the trinomial and the factored form. And lastly, another example again. Z times Z is Z squared. Z times negative 6 is negative 6Z. Negative 1 times Z is negative 1Z. Negative 1 times negative 6 is positive 6. Collect our like terms. We get Z squared minus 7Z plus 6. And again, we can find that relationship. Or if we see that relationship between the terms of our trinomial and the terms of our factored form. And it has that relationship of the two numbers multiply to give me the last one and add to give me the middle one. So when we're factoring, that's what we're looking for. So if I want to factor this, I'm looking for two numbers that multiply to give me the last term, or a product of 10, and two numbers that when I add them, the same two numbers, mind you, add to give me the middle one, or 7. Why? Because my variable is y, that is going to be the first term in each bracket. So I know I'll have two brackets, and they'll start off with y. Now I have to think of what two numbers add to give me 7 and multiply to give me 10. The easiest one to start off with is multiplying to 10, or the product. Right? It's easy. There's fewer options to choose. So what two numbers multiply to 10? Well, 5 and 2. We can test that. Does 5 plus 2 equal 7? It does. So that means that the missing parts of our bracket are going to be positive 5 and positive 2. And then we factored. If we want to check our work for the first one, again, you can check your work for the second one, the other ones, we need to multiply. So basically just kind of going through, see if we end up with the same thing. Y times y is y squared, 5 times y is 5y, or sorry, y times 2 is 2y, 5 times y is 5y, 5 times 2 is 10, and when we collect our like terms, y squared plus 7y plus 10, this does work because we end up with the same thing that we started with. For B, same idea. Two numbers that multiply to give me the last number, or negative 6, and two numbers that add to give me the middle one, which is a negative 1. A is my variable. That's going to be what's in the front of my brackets. So what two numbers multiply to negative 6 and add to negative 1? Well, I know that 2 times 3 gives me 6. If I want to make it negative, either one could be negative, but I want my sum to be negative, so the larger number should be negative. So 2 plus negative 3 is negative 1. So we have positive 2. Let me be consistent here. 2 and negative 3, 2. So a plus 2 and a minus 3 will give me my factored form. And again, you can check that if you want, similar to what we just did. For the last one, same idea. I know I'm going to have two brackets because it's a trinomial, simple trinomial. X is going to be my first term. Now I'm looking for two numbers that multiply to give me 9, and two numbers that add to give me negative 6. Well, two numbers that give me 9 3 and 3. However, 3 plus 3 gives me positive 6. I want negative 6. So if I want negative 6, both of these numbers will have to be negative. A negative times a negative still makes a positive, so that's okay. And a negative plus a negative gives me a negative. So negative 3 is in the first term, negative 3 is in the second term. And that is our factored form. So again, you can go back and double check these answers by multiplying if you're unsure. But again, the main thing that you're looking at is trying to find or use this idea of the product and sum to find your two numbers that are going to go into your two brackets. So that's the key thing that you're looking for. Again, it's for simple trinomials that are in the form x squared or a variable squared plus bx plus c, something in that form. If there's a letter or a number in front of that x squared, we'd have to use a different method, which we'll look at in a later lesson.